Okay, so yesterday we talked about the real number system and we completed these notes and definitions and we practiced classifying numbers, okay? And so what we're going to do today is we're now going to add this information and see how it applies to a Venn diagram. So what I want you to do is turn to the next page in your notebook, and I want you to draw these boxes and label it Venn diagram. You'll notice that I like to use colors when I take notes or give notes, and so I highly recommend investing in a pack of markers. I mean, you can buy a pack of markers at the Dollar Tree for $1. I think it just, number one, it makes it a little more fun, and it also makes your notes more colorful and helps things stand out. So if you'll please draw this, and when you're ready, turn back on your video. Okay, so what we're going to do, and let me explain a Venn diagram, is first of all we need to give our diagram a title. And we are dealing with the real number system. Okay, so if you'll title this the real number system. And so by titling it this, we're saying that every number, everything in this diagram is going to be considered a real number. Now, if you'll remember, and if you need to flip back to our notes from yesterday, we had two main categories of real numbers. We have rational numbers and we have irrational numbers. Okay, so in our boxes, we're going to label that. Now you'll notice over here on the left, we're going to put rational. And over on the right, we're going to write irrational. You'll notice that the rational box is a little bit bigger because there are more numbers that are rational than irrational. This is very limited, okay? Now the good thing about the irrational side is, remember, that is the only number in that category. It does not have any subsets, okay? So irrational side is super easy. But what we need to do is we need to add natural numbers, whole numbers, and integers to our rational number box, okay? So what I'm going to do is I'm going to start with the lowest and the smallest category of rational numbers, and that is our natural numbers. So I'm going to draw a circle. You could draw a box. It doesn't have to be a circle, but that's what I'm going to draw. Okay, natural numbers. Natural or counting numbers. Now, we know that natural numbers are a subset of the whole number category. Okay, so the way we show that on a Venn diagram is we're going to draw a circle around it, and we're going to title it whole. And so what a Venn diagram is saying is that anything inside the whole number circle is also a whole number. And we know that from yesterday, that a natural number is also included as a whole number. So that's why one is inside the other. Okay, and then we talked about that a natural number is also a whole number, is also an integer. So guess where the integer circle goes? It goes around the other two, and we're going to title that integers. Okay, so what this is saying is that everything inside the integer circle is considered an integer. So whole numbers are inside of it, natural numbers are inside of it. Okay, and so that's the way our Venn diagram should look, or any kind of diagram that we look at the real number system. It should look something like that. Sometimes they might take out a category, but it still should build up like this. Okay, so what we're going to do now is, you see that you don't have to write these numbers down. We're going to write them down in just a second. But we're going to take all of these numbers and we're going to place them in the correct location on our Venn diagram. And so what I want you to think about is that we're going to place the number in the lowest category. Okay, the lowest category. And when I say that, I'm referring back to our diagram. I would consider natural numbers the very lowest category. Rational and irrational would be considered our biggest categories. Okay? Okay. So let's start with, I'm picking a color. Let's see, I'll do them in blue. Okay, let's start with 4. Okay? First of all, it would probably help to know, is 4 rational or irrational? Because we have to know which side it goes on. Remember, the determining factor is, can we write it as a fraction? And yes, we can. We can write 4 over 1. So that means it is a rational number. It has to go on this side. So let's start with the lowest category, the smallest circle. And that's maybe another way to think about it, is the smallest circle. Is 4 a natural number? Do we naturally count with the number 4? 1, 2, 3, 4. Yes, we do. So that means 4 is a natural number, and so we're going to put it here in the natural number circle. That means that 4 is a natural number, a whole number, an integer, and it is rational. And of course, all of them are real numbers. Okay, so that's what I mean by putting it in the lowest category. Okay, so we did 4. Okay, let's look at 2/3. Can we write it as a fraction, rational or irrational? It's already a fraction, right? So that means it's a rational number. Okay, so let's look at the smaller categories. Is 2/3 a natural number? Do we naturally count with the number 2/3? Absolutely not, right? I don't count with fractions. I hope you don't either. Is it a whole number? Can we buy 2/3 of a cupcake? Most likely not, right? Okay. Is it an integer? Is it a whole number or its opposite? Nope, it's not. So the only thing it is rational. So we're going to put it here in the rational box. And so that means it is only rational. Okay, let's look at the square root of 17. And I don't have my phone with me. Oh, yes, I do. The square root of 17. Okay, if we take our calculators and we type in the square root of 17, I get 4.1231, on and on and on and on, right? 4.12 ... Dot means it keeps going, okay? So, whoops, that was supposed to be here. Okay, so can we write that as a fraction? If it keeps going on and on forever, can we write it as a fraction? And the answer is no. So that means the square root of 17 is irrational. Okay, 0. Oh, this is a tricky one. Okay, can we write 0 as a fraction? Absolutely. It's a little weird, but it would be 0 over 1, right? So that means it goes in the rational side. Is it a natural number? Do you naturally start counting with 0? The answer is no. If I actually asked you to start counting, you would start with 1 most likely, right? Is 0 a whole number? Now you technically can't, I mean, you can not buy 0 cupcakes, but 0 is considered a whole number, and so we're going to put it there. That means 0 is a whole number, and it's an integer, and it's rational. Okay? Okay, -8. Can we write it as a fraction? Yes, we can. We can put it over 1. So that means it has to go on our rational side. Okay? Is it natural? Do we count with -8? Nope, we sure don't. Is it whole? Can you buy -8 cupcakes? Nope. Is it an integer? Whole number and its opposite. Yes, it is. It is an integer. So we're going to put -8 right here. That means that -8 is also an integer and it is rational. Okay, pi. Now, a lot of times you hear pi and you immediately think 3.14, right? But I hope we know that 3.14 is not exactly what pi is, that pi is this long, never-ending number. And so if it never ends, can we write it as a fraction? Nope. So I'm going to put it in my irrational side. I feel like a TikTok saying nope, yep, nope. Okay, the next one, 6.4 repeating. Repeating decimals are a little bit tricky, and I don't know if you wrote it down in your notes, but I wrote an example that repeating decimals are rational because you actually can write it as a fraction. Okay, so 6.4 repeating, we can write as a fraction, so it goes on the rational side. Ask yourself, do we naturally count with it? Absolutely not. Is it whole? Absolutely not. Is it an integer? Absolutely not. It's not whole, and it's not its opposite. So 6.4 repeating would just go in the rational box. Okay, the square root of 36. I hope you know the square root of 36. If you don't, again, you can type it in your calculator, and we would get that it is 6. Well, can we write it as a fraction? Yes, it's rational. What would be the lowest category? Ask yourself, is it natural? Is it whole? Is it an integer? 6 we would naturally count with, so 6 would go in our natural box. And that means that it's all of these sets as well. Okay, 2 more. -3.4. It's a decimal. Can we write this ending decimal as a fraction? We can, right? So it's rational. Okay, is it natural? No, because it has this part to it. We don't naturally count with negatives. Is it whole? No, because it's 3 4/10. Is it an integer? I hope you said no, because again, it has a part. Remember, integers cannot have a fraction or decimal part to it. So just because it's negative does not mean that it is an integer. So the only thing that this is rational and a real number. Okay, last one. I've given you some examples like this where we have ... which means our number keeps going on forever and ever and ever. And if it goes on forever and ever and ever, can we write it as a fraction? Nope. So we're going to write it here. It is an irrational number. Okay, so please make sure you have this in your notebook and proceed on now to your assignment.